Hello everyone. So today we are going to continue with chapter 6 of grade 11 maths, which is linear inequalities. And in this video we will learn about the graphical solution of linear inequalities. Okay, so let's start. Now to represent the solution of a linear inequality in one or two variables graphically in a plane, we have the different procedures. First is if the inequality involves greater or equal to or less or equal to sign is also there, we draw the graph of the line as a thick line to indicate that the points on this line are included in the solution set. So if the inequality contains greater or equal to or less or equal to, the normal thick line is drawn. Now if the inequality involves only greater or smaller, we draw the graph of the line as the dotted line to indicate that the points on the line are excluded from the solution. Clear? If it is only greater or smaller, there is no sign of equality, then we draw the graph as the dotted line, which indicate that the points on the line are not included in the solution. Clear? So pause and note down these points. Now solution of a linear equality in one variable can be represented on a number line. In one variable it can be shown on the number line as well as the Cartesian plane. But the solution of a linear equation in two variable, that is ax plus by greater than c or ax plus by greater or equal to c, less or equal to c or less than c, condition is that a and b should not be equal to 0, can be represented on the Cartesian plane only. Now if it is a linear equation in linear inequality in two variables, it cannot be shown on the number line. It can be represented only on the Cartesian plane. And if two or more inequalities taken together comprise a system of inequalities and the solution of the system of inequalities are the solutions common to the inequalities comprising the system. It simply means we have to plot the linear inequalities on the graph and the common solution region, whichever region be the common between all the inequalities, will be the solution region for the given system of linear inequalities. Clear? So pause and note down these points. Let's start exercise 6.2. The question 1 is solve the inequality graphically in two-dimensional plane, and the inequality is x plus y less than 5. Now the given inequality is x plus y less than 5. So putting the value of x equals 0, we get y is equal to 5, and putting y is equal to 0, we get x equals to 5. Clear? So plotting these points, we get the solution as shown in the figure. Now the line is the dotted line here because the sign here the inequality contains only less than sign. There is no equal to part. It simply means the points on this dotted line are not in the solution set. Now to know the solution region, this line is dividing the plane into two parts, one above and one below. So which region the solution will be? So just take the origin in the given equality, that is 0 0. So we will get 0 plus 0, that is 0 less than 5. Yes, 0 less than 5. So origin will be in the solution region. So shade the region containing the origin part. Okay, so lower part below the line will be our required solution. Clear? So pause and note down the solution. Next we have question 7. Solve the inequality graphically in two-dimensional plane, which is minus 3x plus 2y greater or equal to minus 6. So we have the inequality minus 3x plus 2y greater or equal to minus 6. So taking this as equation, we get minus 3x plus 2y equals to minus 6. So putting y is equal to 0, we get x equals to 2, and putting x equals 0, we get y is equal to minus 3. So plotting the points, we get the line. Now here we are taking the thick line because greater or equal to sign is there. Now to know which part will be our solution region, we take the origin again in the equality, we get 0 plus 0. In that part we get 0 plus 0. Above the region and below the region we have to take. So what are we getting here? So the shaded region will be our solution region. Now you can solve other sums of exercise 6.2 because all the sums are same. So we are moving to exercise 6.3. And the first we are solving question 2, which is solve the following system of inequalities: 3x plus 2y less or equal to 12, x greater or equal to 1, and y greater or equal to 2. So first we are taking 3x plus 2y equals to 12. So putting x equals 0, we get y is equal to 6, and putting y is equal to 0, we are getting x equals to 4. So graph of the straight line 3x plus 2y equals to 12 will be a line joining these two points, that is 0, 6 and 4, 0. Okay, so let's check the graph. So we have the line 3x plus 2y equals to 12, and x equals to 1 will be a line parallel to y-axis, and y is equal to 2 will be a line parallel to x-axis. Now it was x greater or equal to 1, so it cannot contain origin. So the line x equals to 1 solution will be to the right hand side, and y is equal to 2, again since y is greater or equal to 2, so again origin cannot be there, so the solution for y is equal to 2 will be the above the line. Now coming to the line 3x plus 2y equals 12. Now if you take origin in that part, we will find that the origin is in the solution region. So taking the common region between all these three lines will be the darkened part, the darkly shaded part in the figure will be our combined solution region for the given system of inequalities. It is very simple. Find the solution region of all the three lines individually and then find the common one. The common one is the triangle that is darkly shaded. Clear? So pause and note down the solution. Moving to question 5. Solve the following system of inequalities: 2x minus y greater than 1, x minus 2y less than minus 1. So writing the inequality 2x minus y equals to 1 and putting the values, we get x equals 0 when y is equal to minus 1, x equals to 1 when y is equal to 1, and x equals to 3 when y is equal to 5. And the second one is x minus 2y equals to minus 1. So x equals to minus 1 when y is equal to 0, x equals to 1 when y is equal to 1, and x equals to 3 when y is equal to 2. So plotting the graph for these two lines, we get our required graph as below. As the graph, the equality does not contain equal to sign. Okay, so we have drawn the dotted line for both the lines, that is x minus 2y equals to minus 1 and 2x minus y equals to 1. And again putting the origin, that is 0, 0 in both the inequalities, we will check whether origin is there in the solution or not to get the solution region for the two inequalities independently. And the region common between these two will be our required solution. So you can see in the figure that the darkened portion is common between the solution of both the inequalities. So that darkened portion will be our required solution region for the given system of inequalities. Clear? So pause and note down the solution. Next is question 9. Solve the following system of inequalities: 5x plus 4y less or equal to 20, x greater or equal to 1, and y greater or equal to 2. So we have writing the inequality as equation, we get 5x plus 4y equals to 20. So putting y is equal to 5, we get x equals 0, and putting y is equal to 0, we get x equals to 4. So we can obtain the graph of the line 5x plus 4y equals to 20 by joining these points. And x equals to 1 is a line parallel to y-axis, and y is equal to 2 will be a line parallel to x-axis. So plotting the graph as below. So since the inequality contains greater or equal to signs, so we have drawn the thick lines for all the three lines: 5x plus 4y equals to 20, x equals to 1, and y is equal to 2. And again putting origin in the inequality, we will observe whether origin is there or not to obtain the solution region for the three inequalities. And finally we will get the common region between three lines to get our required solution region, which is shown as the triangle, shaded triangle in the given graph, and that will be the solution region for the given system of inequalities. Clear? So pause and note down the solution. Next we have question 12. Solve the following system of inequalities: x minus 2y less or equal to 3, 3x plus 4y greater or equal to 12, x greater or equal to 0, and y greater or equal to 1. Okay, so writing the inequality as the equation, we get x minus 2y equals to 3. So putting x equals to 0, y is minus 3 by 2, and putting y is equal to 0, x equals to 3, and taking the second inequality as equation, we get 3x plus 4y equals to 12. So putting x equals 0, we get y is equal to 3, and taking y is equal to 0, we get x equals to 4. So x equals to 0 will be the y-axis, and y greater or equal to 1 or y is equal to 1 will be a line parallel to x-axis. So let's obtain the graph as below. Plotting the graph of both the lines, and y equals to 1, since x equals 0 will be the y-axis, and again putting origin in the inequalities. If the origin satisfies the inequality, it will be in the solution region, and if the origin does not satisfy the inequality, it cannot be in the solution region. So taking the common region between the solution region of all these four, we get the shaded region as the common region, shaded as shown in the figure. So the shaded region will be our required solution for the given system of inequalities. Clear? So pause and note down the solution. So next we have question 15. Solve the following system of inequalities, which are x plus 2y less or equal to 10, x plus y greater or equal to 1, x minus y less or equal to 0, x greater or equal to 0, and y greater or equal to 0. So writing the inequality as 3x plus 2y equals to 150, we get if x equals to 0, y is equal to 75, and if y is equal to 0, x equals to 50. Taking the second one, so x plus 4y equals to 80, we get when x equals 0, y is equal to 20, and when y is equal to 0, x equals to 80. And we know that x minus y is equals to 0, that is equals to y, is a slant line making 45 degree with the axis. So plotting the lines, we get the required lines as x plus 2y equals 0, x plus y equals to 1, and x minus y equals to 0 as shown in the figure. Now to decide the solution region, we simply take the origin. If the origin is falling in the solution region, the solution region will be up to that side, and if the origin does not satisfy the inequality, it won't be in the solution region. So you can see in the graph that the solution region is shown as the shaded region, which will be the common solution for all the inequalities given over here. Clear? So pause and note down the solution. With this we end the chapter and solve all the remaining sums as well as the examples given before the exercise. Thank you and all the best.